Hey everyone, it's Justin again. Today we're going to learn how to graph lines when given a linear equation in standard form. There are two main ways to do this that we'll discuss, and then you'll get a chance to compare these methods and decide when it's best to use each of them. I want to start you off with this equation in standard form. Let's see if we can figure out how to graph this. Well, you know that we need 2 points to graph a line, so let's try finding 2 points. We know the domain of this is all real numbers, so in order to find a point on the line, I can substitute in any x value I want to, and I'll get out a y value. Let's just try 5 for x so that we can think through this together. If we substitute 5 in here for x, can you solve this for y? Try it now and see what you end up with. Here's what I got for y. Now, we could repeat this process with a different x value to find another point and then make our graph, but it would be nice if there were fewer steps to deal with when solving for the other variable. Maybe there is a way to make this process quicker. Let's look at the graph of its line to see if we can find anything useful. Well, I know that doing any operation with a 0 is quick and easy. These points have 0 in them. What are the special names for these points? Yeah, they're the x and y intercepts. For any x-intercept, what's the y value? Yep, the y value is 0. And for any y-intercept, what's the x value? Yeah, the x value is 0 too. Try substituting each of these points into the equation and see if you notice anything that might make solving for a missing coordinate easier. I am a big fan of substituting 0 in whenever we can. Maybe you can figure out why. Well, the nice thing about substituting this x-intercept in is that this y term, 2 times 0, is just 0. It's like the y part of the equation just cancels out, and all we have left is that 3 times 4 equals 12, which is true. I do enjoy when terms cancel out. Did you notice something similar with the y-intercept? When we substitute 0 in for x, we get 3 times 0, which is 0. It's like the x part of the equation just cancels out, and all we have left is that -2 times -6 equals 12, which is also true. So, this is a pretty cool observation, but how does it help us more easily find 2 points so we can graph a line from standard form? Well, we know the x-intercept means that y has to be 0. So if I hadn't already told you what the x-intercept is, couldn't you solve this equation for x to find it? You sure can. 2 times 0 cancels, and we just have 3x equals 12. Dividing by 3 gives us x equals 4. And that's exactly what the x-intercept is here. Could you approach the y-intercept in a similar way? The x value will be 0 this time. So can you use that to solve for the y-intercept? We already know what it's supposed to be. Can you get there on your own? Sure. 3 times 0 is 0, so we solve this and get -6. Now, once we have these two intercepts, how do we get this line from them? Well, we just need to draw a line that connects them as accurately and as straight as possible. This leads us into our first method of using intercepts to graph equations in standard form. Let's give this a try. Actually, why don't you give this a try? I bet you could do it without me. Graph this line by finding the x and y intercepts. Remember to substitute 0 for y to solve for the x-intercept, and substitute 0 for x to solve for the y-intercept. Then, put those points on a graph and sketch in a line to connect them. Pause the video now and work through this on your own. When substituting 0 for y, we have that 3 times 0 is 0, leaving us with just 6x equals -12. And dividing by 6 gives us that x equals -2. So we can plot the point -2, 0 on the graph. Then we can use that same strategy to find the y-intercept. When substituting 0 for x, we have that 6 times 0 is 0, leaving us with just negative 3y equals negative 12. And dividing by negative 3 gives us that y equals 4. So we can plot the point 0, 4 on the graph. Now all we need to do is connect these 2 points and sketch a nice straight line to finish the graph. Now, this method of using the intercepts to graph can be really handy, but it does have its limitations. I want to give you a chance to explore what I mean. Give this problem a try using the intercept method. So, what did you get for the x and y intercepts? Yeah, if we check out my work here, we could see that the x-intercept is 0, 0. And the same is true for the y-intercept. Well, if we only know one point on the line, how are we supposed to know where to draw the entire line in and how steep to make it? I mean, there are a lot of lines that can be drawn through this point. We have to determine exactly where our line is supposed to go. Well, the intercept method can be really handy, but if this happens, I recommend using a different method. We can actually change the equation to slope-intercept form, and then graph it using the y-intercept and slope like we're used to. Let's go back to that problem again and try this out. Since trying to find the intercepts for this problem wasn't very helpful, let's change this to slope-intercept form instead. Slope-intercept form requires the y value to be isolated on the left side of the equation. Can you solve this equation for y? In other words, can you get y all by itself on the left side of the equation? Give it a try. Go ahead and pause the video and see if you can change this to slope-intercept form. We need to move the x term to the right side. Then, dividing by y's coefficient gives us slope-intercept form with a slope of negative 4 and a y-intercept of, well, 0. So now that this is in slope-intercept form, go ahead and graph it. Pause the video now. Using the y-intercept and slope gives us this line. Okay, so in this case, where the x and y-intercepts are both at 0, 0, this seems like the better option. Now it'll really be up to you to decide which method to use to graph from standard form. Sometimes one will work better than the other, or just be more efficient. So in this example problem, go ahead and see if you can graph this using both methods. Then decide which method you prefer. Pause the video and take all the time you need. Let's go over finding the intercepts first. Here's my work for finding the x-intercept. And for finding the y-intercept. Then I can connect them to make a line. It seems like finding the intercepts is an okay method here. It works fine, but I'm not loving the fact that I'm having to graph a fraction or decimal. It's going to be tougher to make sure that my graph is accurate. Well, there is always the other method, so let's try that. If we change this equation to slope-intercept form instead, we'll need to get y by itself on the left side. In order to get y isolated on the left, we need to move the x term to the right. Then we can divide by the coefficient in front of y. And now that we have this in slope-intercept form, we use this y-intercept and slope to graph the line. Using the y-intercept and the slope of up 7 right 3 or down 7 left 3 gives us this. It's the same graph we got using the intercept method a moment ago, but I like that this method did not involve graphing fractions for this particular problem. Now, you can get fractional points using either method, but if one method is giving you a tough time for the problem you're working on, it's usually a good idea to try the other method too. Now you can graph linear equations that are in standard form. Remember the two methods I showed you. Using the intercept method can be a great, quick way to cancel out terms and find 2 points on the line. But if you have a special case that is giving you any trouble, changing the equation to slope-intercept form is always an option too. Be sure to finish up the guided notes that go along with this video. Then focus on the activity that comes next in your PDF. It'll be a great way for you to learn some strategies that can make your graphing skills even more efficient. Then, to finish up this lesson, you'll complete the online practice game. Good luck with that, and I'll see you next time.
Hey.